Welcome to another exciting edition of CG Programming and Development. This is Nate Nestler with Hyperactive Studios. Alright, so what we did earlier was some mathematics with some images, and that was kind of cool, but now we kind of got crazy with it. I got rid of the teapot. Teapot's kind of boring, and I moved over to the spaceship because that's more exciting. Let's face it, it is. Alright, so how did I get these other textures on here? Well, let me show you real quick, but first let's talk about what's happening here with the mathematics on this texture. Okay, so I've got this texture of the checker pattern assigned to the blend texture here that I created a variable for, and then I got this other one for my diffuse texture, or my main texture, if you will, for my which is basically the spaceship. Now again, as we talked about earlier, anytime you multiply times white, which is 1, you get itself. So that's what's happening here. And then we did a multiplication. Check it out. I've got my diffuse color multiplied times everything, but mainly I have my text 2D here, color sampler 2, n.textCoord. Now what that is this checker texture right here. And I'm multiplying it times with a gradient value going in here for changing this variable affects my diffuse texture here. And so when I'm multiplying it times the diffuse texture, then we got basically two sets of controls here for colorizing the textures. And I'll show you what I mean here real quick. I can grab this and yep, I can change the color on the fly everywhere in effects with that texture. And that's very cool and really nice. But you know, as you can see, it's not changing the black. Well, why not? Well, why? I said earlier, remember, black is 0, so anything times 0 is black. So it's not going to affect any of these black areas. It's getting cut out, if you will. And then that's the effect of a multiply, as far as that goes. Now, I can show you, and this is very stark, you know, because we're not getting any kind of variation between it, because it's purely just white or purely just black, as you can see in this texture pattern. It's just purely white or black. Okay, but I'll show you real quick how to get this image over here onto this model. So if I drag and drop, I left drag and drop this from there to there, I just drag and drop it onto the blend diffuse texture, and I swap it out, and pow, there it is. I have swapped out that texture. And now they are basically being multiplied together. So everywhere it's white, you're getting full value of the diffuse texture, and everywhere it's black, you're getting total black, and then gray is a mixture of the two. So the cool part about all this is that we're getting some kind of blend going on, and that's not bad. And you can use this for all kinds of crazy cool stuff. Now if I go ahead and start playing around with these colors here, you can see it being changed around on the fly as I manipulate this color. Alright. Very cool. Let's try playing around with the mathematics a bit more. Okay, so if I drop this out real quick, and then I come back over to, let's use a Lerp. Good old Lerp. Let's break out the Lerp at this point. Let's do a save all, build, and compile. Whoa, hey, cool, check it out. We get a totally different result. Reason why? Because we're doing basically a mix. If you're used to seeing a mix in Photoshop or GIMP or any of those kind of programs, you're basically doing a Lerp, or a linear interpolation type mathematics thing, where we're blending the two images together, doing a mix. And I've set this up already to where I could actually change the tick value on this thing. I set up a special TextureBlend variable. So let me show you this. If I click here, I get a drop down box here, combo box as it's called in programming. If I click this right here, I get a drop down and it pops up with a slider, and I can change. Whoa, look at that ship right there. As I drag this back and forth, and I have a thousandth of a precision here with my ticker for my step size. And as I move it back and forth, I can blend between the two images. Now this is super cool. Just think about this. This has some pretty strong implications. You can have a regular texture, your diffuse texture for your vehicle or some kind of main character or something like that, right? Or maybe the enemies, for instance. And then as they take damage, you can just simply start blending here between one texture and another, right? So you can have like the damage texture underneath the main one here, and then as you blend over here like this, it looks like the ship is taking on more and more damage. Very simple, very easy to do, and very cool nonetheless. Okay. Let's look at how I did this now, because this is cool, and you should know how I pulled this off. I like to be exactly at 5.0. Okay. And again, of course, I can come in here. Sorry, I should mention this. I can change my colors around too on here, which isn't going to have anything to do with gradient since it's not in that calculation. But this one will be. Yeah, so as an overall, yeah, here we go. So we still have an overall colorizing control. Now, we can get a little crazier with this and start playing around with the color scenario. And what we can do is come up here and have a look at what on earth I did. Okay, so here's my const float text blend. Okay, and basically what that means is this is this variable right here that has a drop down slider, and I just did it as a const float, so it's a uniform, meaning it's not going to change per pixel. It's only going to change overall, and that's all we care about really. It's a blend. You're not going to have it. It needs to be a uniform for performance reasons. And then we have an annotation here, and in the annotation here I use a string, and the UI widget equals slider, and a special name here, slider, means it's going to, when I click on here, pop up and give me a slider. So that's important. UI name equals TextureBlend, so that gives me this name right here, TextureBlend. And then float UI min is the minimum value, right? So what's the minimum value of my slider? 0. Well, that makes sense, because think about it, and when I'm at 0, 0, totally at 0, I am at one texture, totally one texture, and none of the other, right? And when I'm at 1, 0, exactly, I'm at completely the other texture and none of the other one, right? So very cool. That works out exactly like we want. And then here I can set the step size. Now right now it's set to 1/1000th of a step size, but I can change this. So say I make this 100th, right? Save, rebuild, compile, go ahead and click and pull this up, and check it out. It's going to start manipulating it by the hundredths and not the thousandths. You can see a difference there already. And I could set this to tenths if I like. You couldn't really go less than tenths, really. It'd be hard. Right on 5.0. Alright, so let's make it less than a tenth. Let's make it a tenth, I mean. Not less than a tenth. Well, you could do less than a tenth, like point. That'd be stupid. You could do it. It's just wouldn't make a whole lot of sense. Okay, so now it's going to snap accordingly by tenths. Now, I'm going to tell you right now, for artists, they're going to really want thousandths place so that they have total artistic control, and so that they can nudge it and tweak it and everything like that. Artists love to tweak, and they love to get values exactly the way they want for the look they want, and they know, and it's a good reason for them doing that too, because they are trying to get colors to balance out perfectly, and warm and cool colors and all this fun stuff for doing the art. So it's really important that they have that kind of control. So you definitely want to give it to them for the most part. But here it is at 1.0. I can bring it back to a thousandths because it's going to give more precision and more control to the artist. Okay, so that sets up my blending variable, but it doesn't assign it to anything and doesn't give us the other texture. So let's see how I got the other texture. Alright, so I set up a texture here, a texture color, texture 2. And then an annotation here and where it is on the hard drive. Notice I did double slash. This is because of the escape sequence. Now I didn't talk about escape sequences earlier, but a single slash and then something will make an escape sequence. For instance, slash B usually is a beep in C++. There's other ones like slash N, there's new line character. There's a whole bunch of different ones you can have. If you want to escape an escape sequence, because a slash is an escape sequence, you have to give it 2 slashes. So if I want to do a single slash like that, as you normally would, inside of quotes I have to do double slashes in order to get to escape the escape sequence, which would mean 2 slashes will give me a single slash like that when I do a double slash inside of quotes only. That does not count outside of the quotes. It's not going to work like that. You will get double slashes outside of quotes, but inside of quotes you have to use double slashes if you mean to get a slash there and not an actual escape sequence. Okay, so that's what's going on here. So in order to do E:/ hyperactive studio / so on and so forth, spaceship fighter / so on and so forth. Over here, UI name, I set equal to blend diffuse texture, and quotes and semicolon. Now, I didn't do this by relative reference here for my name. I did explicit location. Now, if you're doing this for real production needs or whatever, you do not do absolute directory paths, because if you do, then what's going to happen is, say they don't have an E drive on their computer, say they only have C drive. Well, it's not going to work. Your program's just not going to, function or whatever. So that really matters. You can't be guaranteed on something like that. Whereas if you have everything within a project folder and this file is relative to this file, and so many folders over or whatever, then everywhere someone moves that folder, it's okay and it works. So for pure functionality and keeping things working, it's a good idea to keep things relative with your path names. But for this circumstance, I didn't. I just put it there. But I should have made it relative. I just lazy. All right. So string resource type equals 2D. So it's going to be a 2D string. Okay, cool. And then I made another texture sampler, and so I'm calling my second texture here from my second sampler. Now that's important. I call it color sampler 2. I could call it whatever I wanted, but I called it just 2 because I'm lazy. And I'm calling my color texture 2 from my sampler 2. And that's important because from my sampler 1, I'm still calling the first texture. Now if you aren't careful and you end up calling the first texture from the second sampler, then you just call the same image. And therefore, anytime you change the image on one, it changes on the other. And that's not going to work well. It's a real problem. It's really not a good idea. Because you'll end up changing the image for both of them when you change a single image thing over here, and then this one wouldn't be assigned to anything, and you could change it to whatever you wanted and it wouldn't do anything. So that would really matter. So min filter equals linear, map linear, semicolon. We already talked about this earlier. Mag filter equals linear, semicolon. Wrap s equals repeat, semicolon. Wrap t equals repeat, semicolon. Just like before. Close curly brace, semicolon. And so that sets us up for another texture sampler. And I've already gone through that and explained it in detail. If you need more information on that, please go back to the previous video and watch that video again. Alright, so we have our calculation here. Let's see the Lerp. So what's going on here? We have our out color equals to diffuse color times a Lerp, and then inside parentheses we have a text 2D, and then close parentheses. Open another parentheses. Color sampler 2, comma in dot text chord, close parentheses, comma text 2D function here, and then we're doing a color sampler for the first texture, right? Comma in dot text chord, close parentheses, comma, and then TextBlend. So again, TextBlend is our in between here, and remember our color sampler 1 is going to be talking about this image here, and our color sampler 2 is going to be talking about this image here. So we're doing a linear interpolation between these two textures, and we're controlling it based on the value from this variable here. That's essentially what we did, and that's how we tie all those together with just that one little mathematical expression. Nice and simple and beautiful nonetheless. Okay, and the rest of this technique, everything has not changed one bit. It's all completely the same from before. Okay, very cool. Now let's talk about some other mathematics here real quick. And I'm going to go back to where I was playing with the math earlier. Save all, rebuild, and compile. Okay, cool. Now we got a brightening effect. Why do we have a brightening effect? Well, it makes sense, kind of. So what has happened here? Well, I've done several things that would cause a brightening effect, honestly. We have... Okay, let's go through the mathematics first. First and foremost, mathematics. Okay, so what if I wanted to inverse an image and change its black to white and white to black? How would I do that? Well, you can do it mathematically. It's really no problem. So if I do... well, think about it. If I do white, which is 1, times -1, what am I going to get? I'm going to get -1. So again, here we go. We have our white times -1. You get -1, right? Because anything times 1 is itself. And then if I add 1 to it, I get 0, which is black, right? Now if I take black and I multiply it times -1, I get black, right? Because anything times 0, black, is black. And then if I add 1 to it, I end up getting white, right? So this means all the regions where it's black on the image are going to become white, and all the regions where they're white are going to become black. And this essentially means I just inversed my black to white and white to black mathematically with the same exact algorithm. So how's the algorithm go? You multiply the color first times -1, and then you add 1 to it, and that lets you inverse it. And this only works from 0 to 1 colors. This does not work for over brightening HDR colors where they go above and beyond 0 to 1 scale. So if you have colors going outside of that range, then this calculation won't work for that, but it does work for 0 to 1 colors. So very nice. Okay, so if we look at this real quick, this is precisely what I've done. I've done a float for, and let me comment that out again. I didn't do that earlier, and I had to go back and check out what went wrong. I had this typed out down here. Of course, that's not valid code for nothing, you know. It's just for an explanation purposes, explanatory purposes. All right, so out.color equals diffuse color times, and then here comes our interesting algorithm here. So here I got a float 4, so for RGBA, right? So I did -1, -1, -1, and 1. So it's going to apply it across all the channels here of RGB from this texture here, which is the second one. And of course the second one is our black and white image, this one right here. Okay, cool. And then what happened after that? Well, after I multiplied it times that, then I added it to 1.0, 1.0, 1.0, and .0. Why not on the other one? Well, same reason here. Alpha, I don't want to change it. I do not want to make alpha negative. I do not want to make alpha transparent to where you can't see anything. I want to keep alpha the same. But I'm sitting here going 1.1, 1.1, 1.1 to add back to the other color. So where it was black is now white, and where it's white is now black, and alpha stays the same. Okay, cool. And then I'm simply just adding it to my other texture, which is my overall machine one here, and I'm multiplying it times the gradient color. Very cool. So here's our gradient color. It's back in play now. But you can already see a different effect from this. And check it out. We are getting coloring in some places, and other places we're not getting any coloring at all. Very cool. Very cool indeed. Okay, so I'm breaking down this next calculation here for the inverse color part into, well, two parts for this formula. Anytime you get a formula that starts going on really long, like this one was, and it was going way off the page, then it's time to break it down to two parts, and you don't get any penalty for doing this. The assembly on this is going to come out fine. It's going to look great. It's not going to be any kind of slowdown. So anytime you have one of these variables here where you can have it reused, you can rename it, and can simplify a calculation, is by far the best thing to do, is to do that. Again, no performance hit for doing this, so by all means please do this. It makes your code easier to read and easier to follow. So this gets into our inverse. Now what I've done is I've colorized one color, and then I've colorized the other part of the same texture. Now I've taken the same texture, this one right here, that's applied to it, and you can notice it is black and white, and there's no colors on it whatsoever. Yet I got two totally different colors coming from the same image. The way I've done this is I've inversed the image and multiplied it times one color, and then kept the image as it was and multiplied it times a different color, and then added the result together. And this works together. This works great, because what happens here with the mathematics on this, when you add colors together, say I have white, right, and I add it on top of black, because if I inverse the image, everywhere there's black it's going to be white, and everywhere there's white it's black. So this works, right? I do something like this, right? No problem. So that would add together, and I get 1, and I don't get over a brightening effect. So realistically, if this was some kind of color here, say it's like 7.7 or something like that, you'll get this color wherever there was black beforehand, and so we don't get this darkening effect happening. And this is literally how you can do the Master Chief, type armor. Check it out. I'll just prove it. I can sit here and colorize all those areas. I just like the yellow. I don't know. I like it. Orange is nice too. It's nice too, but the yellow, I don't know. I like the yellow. The yellow looks good to me. And then come over here to this other color, and I can start messing with it. And it's an inverse. Of course, yellow is just way too yellow. And then, this is all getting, conformance with the other texture here is, being handled also. So, no big deal. I'm adding the other texture to it. Now I could multiply this texture times it, and I would get a nice result for that. But let's look at this calculation real quick. So this is how this color is happening. So when I add these together, because I inverse these textures first before I colorize them, I'm not getting a brightening effect from it. And that's why I don't get these overblown values. Normally when you add together, you do, because you're going to get values on top of values. But because I'm adding black to white and white to black, I don't get an over brightening effect. Instead, I'm filling in color where there was total blackness before, and I'm adding color in where there's total blackness previously when it was flipped, where it was white. So this way I can double colorize with one image. That's the key point here, one image, and I get two different sets of colors from a single mask. That means I don't have to have as many mask images in order to colorize my whole model. And it saves lots of computation time. This is very efficient and this is very fast. So this is a great method for doing this. Okay, so what I've done here is I've created a variable, float4, so it's RGBA, and I call it inverse color. Alright, and so I have to set up two parentheses on this because this gets a little hairy. And I have a float4 here, and again I'm going to multiply it times my negative 1. So negative 1, negative 1, negative 1, and then positive 1. For alpha, because I don't want to get my alpha to be inversed. It just makes a whole lot of sense. You don't want your opaque objects to suddenly become transparent. That's not a good idea. Okay, and then so float 4 here, and I'm multiplying this times my color sample. So everything that was black is still black, and everything that's white is now negative 1. And then I'm going to add it 1, 1, 1, and then 0 from alpha, because again I don't want to mess with my alpha. And so now everything that was black is now white, and everything that was white is now black. And then I'm just multiplying it times the gradient color, which is this one right here in blue, and it's colorizing that. Then I come down here and I add my inverse color, which was this flipped. Basically, I flipped this gray scale backwards, upside down. And so what was white is black, and what's black is white, and gray and mid gray is still mid gray. Of course, no matter how you calculate that, it's going to come out the same. And now I'm adding it to the same texture again, but this texture is being colorized by the diffuse color, which is yellow. And then I'm just adding it to my overall one here, which is this base diffuse texture. Now I can get a little fancy with this. Here, if I want to play around with this a bit more, I can sit here and come down to this part here, add a parenthesis there, and this part here. There we go. And then change that from an add to a multiply. Save, rebuild, and I messed something up again. I really gotta stop going off the script. Alright. I'm sure it's really something stupid simple. What have I done? Oh, dude. It's this right here. I went to explain. I was like, I can't believe that would screw up. It's something that simple. Oh, but it's all possible. There we go. So here I'm getting a better blending effect basically by doing this, right? So I've inversed these, add the result together, so now they've got two-tone going on. I don't have any super black regions anymore. And then I'm also getting to multiply it times the base texture here for colorization here. And that's nice. I could have done a linear interpolation here. That could have done that. That would have been nice too. But basically I got a very nice result, and it looks very cool, and I have no more super dark black areas anymore. They're all colorized, so they're either blue or yellow right now, intermixed with my default texture here. And the cool part about this is now I can have this as my main character or some enemy characters, and it's no problem. I can easily change up the look of this ship so easily, it's not even funny. And this would really save a lot on resources and stuff to make it look like totally different ships with very little work or effort to make that happen. So, and that's the point. And here now I got a green and red type set up here, and it looks very different than the other one. and very cool. And so if you're doing like a little shooter game where you sit there and make a whole series of enemies, it's the same enemy. You don't have to do anything different. You can sit there and just literally use some mathematics with the color, multiply things out or whatever, and get totally different looking enemy ships and go, oh, this is the more tougher one, here, this is the more difficult one that you're fighting, or something like that. It just really doesn't matter. And this is great for if you're doing like little tiny games like on a handheld or cell phone or PS3, for like arcade, or like Xbox Live Arcade, XBLA is the business term for it in the industry. But you can use all these different these techniques like that in order to keep your super small size requirement you have to have for deploying on some of these devices, and keep making things look interesting and very cool without having to give up a lot of resources. So this gives you more artistic control and more artistic flair with less work and less overhead and smaller sizes, and it's just neat. Anytime you can sit there and do more with less, the better off you are. Because you can keep the size down small, it means you save memory, it means you save resources, which means the game can look a lot better with a lot less. And that's always the name of the game. We're always pushing the envelope to the absolute maximum here. And we try to see, hey, can we make this piece of hardware that really isn't all that fast, make it do incredibly ridiculous things, And honestly, the 3D cards are insane now. They're absolutely incredibly cool. But even so, trying to reproduce total reality on them, that's very difficult because reality is very detailed and takes up tremendous amount of computing power. It's insane. We'll probably never ever reach total visual exactness with reality, but I think we will reach a point to where it looks like film here in the next generation of games here for our next gen games. So, with 600 million polys, you're talking about some really nice looking stuff. And then with some smart tricks here and there, we'll get the speed up even more on stuff. So, I think that's just pretty much a guaranteed thing to happen here eventually. But hopefully you found this interesting and very helpful, and you can use this for a lot of other things too. And you could do some clamping on stuff like that, where you apply different colors to certain areas of the images, and you can do all kinds of crazy things like that too. So, this is not just one shot thing or one way of doing it. You can do a lot of different techniques for handling this, and this really does create for quite an interesting setup here. Again, my name is Nate Nestler, and this is for Hyperactive Studios, and thank you for watching.